Let's try and put all this together. We've been looking at three main concepts, or equations if you want. One of them is just momentum. We said that momentum is equal to mass times velocity. Momentum is not the same as impulse. This is not the same as change in momentum. We also said that impulse, or change in momentum, we can find that by going m mass times the change in velocity, or force times the change in time. I got sloppy. Time is always a change in, and so I didn't bother writing the delta. And then what we did, Nick, is we broke mass times change in velocity into mv final minus mv initial. You might also notice, Nick, I'm being really nitpicky with my vectors to remind myself if I see words like north and south, or east and west, or rebounds is a trigger word for me, or changes direction, then I have to let one way be positive and one way be negative. Both of these are used for one object. When we have more than one object, when we have collisions, or when we have, you know what? When we have jeunes, when we have collisions, or when we have explosions, when we have two objects, we're using the idea that the total momentum that we start with, wham, they collide, or bang, they blow up, has to equal the total momentum that we finish with. And so we write every momentum starting as mass times its velocity, and every momentum ending as mass times its velocity. And then, Rohan, we can figure out what's missing. So these are the three approaches. These are for one object. This is for a collision or an explosion, two objects. So I see two objects. This is probably going to be conservation of momentum. I see a collision. Oh, sorry, I can see some of you are bothered. Fine. And Surkey. Caleb was looking at that and going, must do that first, Mr. Dueck. Fair enough. I see the word north, so I see north and I see south. I'm going to let north be positive and south be negative. You could let the opposite be true. We'll all get the same answer. I'm going to call this mass A. I'm going to call this mass B. North, south, collision. This is a job for conservation of momentum. I like to write this down because this reminds me that I have more than one object and there is a collision, and this is my one-size-fits-all approach, in the same way as for forces our one-size-fits-all approach was winner minus loser equals ma free body diagram. So I like to, you don't have to, if you want to just say I'm going to go straight to mass times velocity, I'm fine with that. Before the collision we have mass A, velocity A initial, and mass B, velocity B initial. Both are moving and they're not stuck together. Wham! They collide. Stuck together. What am I trying to find? Looks like the final velocity of both players immediately after the collision. Mr. Duke, why did you say immediately? Well, I know on grass you come to a stop really quick. So technically, if you ask me, what's the final velocity after a tackle, Dakota? Well, eventually it's going to be 0. But I want right after the collision, immediately. Okay, they want me to get this by itself. How will I get that by itself? I'm going to divide the bracket. The left side is going to drop down like a domino. How much room? Did I give myself a whole page? Good. Mass A, VA initial, plus mass B, VB initial. Going to divide by mass A plus mass B, and that's going to equal V final. And now I've got it to the plug and chug stage. What was the mass of object A? 82. Velocity, positive 7.5, plus object B was 65, negative 8.1. divided by 82 plus 65. This guy was going faster, but his mass is lighter. This person is going slower, heavier mass. I'm not sure who's going to win this head-on collision. This is pretty close. I'm going to have to crunch the numbers. 82 times 7.5 plus 65 times negative 8.1. Close off the top. I missed the 8. Divided by bracket 82 plus 65. Close off the bottom. You get 0.6? Positive or negative? So what direction? I said north. Now, if you had let north be negative, you would have got negative 0.6, and you would have said, oh, I let north be negative, north. So I'm going to end up with V final equaling 0.6, what was it, Mr. Dueck? 0.60 if I go to 2 sig figs, 0.602 if I go to 3 sig figs, go to 2 or 3 whenever possible, meters per second north. Okay. For 3 marks, how would I give out part marks? I would probably give you 1 mark if I saw that line somewhere, because that's the key. I would give you 1 mark if I saw this line somewhere. I would give you a half mark for the magnitude and a half mark for the direction. Now, if you didn't know how to do any of this and you left it blank, but I saw that you had written that down, I would give you a 0.5 out of 3. I would say, hey, you figured out that it was conservation of momentum. Should be rewarded, because we've learned a lot of physics this year so far. Okay? There is going to be some kind of a head-on collision like this, where they stick together. Could be cars, could be hockey players, could be arrow hitting a target sticking together, although the target is usually at rest, so that makes it easier. You don't have 2 objects moving at the beginning, you only have 1 object moving at the beginning. Number 2. The key word here, Ajne, is rebounds. Rebounds. Because that means there is a change of, I'm looking for a word that starts with the letter D. Yeah, there's a change of direction, which means I better let one way be positive and one way be, okay? Here, I'm going to let up be positive and down be negative, because that just makes sense to me. What does it want me to find? It wants me to find the impulse. So if I look here, this is the impulse. Now, there's 3 ways to find the impulse. They can give me a force and a time. They can give me a final and initial velocity. The third way, because change in anything is final minus initial, they could actually give me the final momentum and the initial momentum, and I would just go, oh, final momentum minus the initial momentum if they told me the numbers. That's kind of redundant, but that would work. Here, I see 2 velocities, so I'm going to go impulse equals mass times change in velocity, but since change in anything is final minus initial, I'm going to go mv final minus mv initial. I also noticed that this was grams. I actually crossed it out and said 0.052 kilograms. Probably on your test, definitely on your test, there's going to be at least 1 question on the written section or on the multiple choice where I give you a mass in grams, because we're getting towards the end of the year and I can do some unit conversion review. I may also give you a velocity in kilometers per hour. You'll have to convert it to meters per second. 0.052 times 6.2 plus 0.052 times negative 8.2. Another nice version of this one, Austin, is instead of bouncing off the ground, bouncing off of a wall. That one, kids miss the change in direction more often for some reason, even though to me it's the same question, bouncing off the floor, bouncing off the wall. I guess you're more attuned to a vertical change in direction than you are to a horizontal. I'm giving you a hint about your test. That's one to look for as well on one of my versions floating around out there. 0.052 times 6.2 plus Mr. Dueck? Minus Mr. Dueck. Geez, copy the equation down correctly. Minus 0.052 times negative 8.2. That's important because that gives me a minus, which is a plus. Did you all get an error, Mr. Dueck? Oh, minus. Did you all get 0.7488? I I see people nodding. 0.749, 0.75. I'd take that. I'm going to write the whole thing because I think I'm going to use this for part B, and then I'll round off. So I'm going to write 0.7488, and then I'll go 0.749 units. Momentum is kilogram meters per second, so change in momentum or impulse is kilogram meters per second. You could also write Newton seconds. I'm not done. What did I write in brackets, Amon? Magnitude and? What direction is this? How do I know? Positive. Are you positive? I'm positive. Nothing? Okay. Up. How would I mark this? If you got the right answer, 2 out of 2. If you botch the units, I take a half mark off, as always. Otherwise, I would give you a half mark for that. I would give you a half mark for the numbers, half mark for the 0.749, and then a half mark for the direction. B, average force, or I could have given you the force and said find the time of impact. Why did I say average force? Again, I'm a physics nerd, Harry. I'm hedging my bets. I have a feeling here the force isn't constant, so all we're able to find is the average force. A changing force we need calculus for, if you're wondering why the word average appears so often. So the average force of impact, well, now I'm going to use force times time equals impulse. Now I'm going to use force equals impulse over time. Now I'm going to use 0.7488 divided by 0.15. That's going to give me the magnitude divided by 0.15, and I get 4.992. I'll go 4.99. 5.0, I would take that as well. It's a force. What are the units? Direction, well, I got a positive force. What direction did we let be positive? Is it 4.99? Did I do it right? Yeah, sorry, I forgot to ask. Same as before or very similar, I would give you half mark for that, half mark for the numbers, half mark for the magnitude, and a half mark for the direction. Then I think I'd turn the page. How many masses in question 3? I only see one, so I already in my mind know, I'm not using that. I'm probably using momentum, or if there's a change in momentum, impulse. Let's go see. They want me to find the average force. You could do this. Don't write this down. That would give you an acceleration, because I do see a VI, a VF, and a T. And then you could go F equals ma, and you're good to go. It's a couple of lines. I'm lazy. The nice thing about the impulse equation is I can do it in one fell swoop. So I don't care which method you use. This is also why I said the impulse equation is kind of redundant. It's a shortcut, but anything that we really find with it, we could find with other methods. I'm going to say, you know what? Force times time equals mv final minus mv initial. Or I think the way I mentioned it to Coda during the lesson, I said I'm going to write impulse equals impulse. It's just the two different ways. And they want me to find the time. I'm going to do that on a separate line just so I can give you marks for it. But if I was writing this myself, that's how I do it. I'll write it on the next line. It's going to be mv final minus mv initial all over time. The mass is 1200. The final velocity is 25 minus 1200. The initial velocity, I did a quick check. I don't see any changes in direction, so I called the 25 positive. I'm going to call the 12 positive all over 8. 1200 times 25 minus 1200 times 12 all over 8. I got a times sign in there, Mr. Dueck. minus, let's try that again. You get 1950, is that right? People are nodding. Units, it's a force, so newtons. Direction, I didn't ask for one because I didn't give you enough information to give me a direction. That's why I said magnitude of the force. If you got that right, 2 out of 2. Otherwise, I would probably do something like half mark if I saw that. Half mark if you got the F by itself. Half mark for the numbers. And a half mark for the answer. Did anybody use the F equals MA method and find A by going VF minus VI over T? If you did, I would give you full marks. You get the same answer. Ooh. Find the change in velocity. Well, change in velocity, Robert, is that thing there, delta V. And so I already started looking at this. Did they give me a force in this question, Robert? Say yes. Did they give me a time? I said, you know what? I think I can go like this. Impulse equals impulse. Again. How would I get the delta V by itself? Oh, so you're telling me the change in velocity of an object is the force times the time divided by the mass? I guess. The force is 120 newtons. The time is 8 seconds. The mass is 40. I think I can do this in my head. 120 divided by 40 is 3 times 8. 24? No? Yes? So the change in velocity is 24 meters per second. What does that mean? It means if your initial velocity was 0, your final velocity was 24. If your initial velocity was 5, your final velocity was 29. If your initial velocity was 10, your final velocity was 34. Your velocity changed by 24 meters per second. I would give you 2 out of 2 if you had that. Otherwise, I would probably go something like half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. And then collision. Hockey is nice. In some ways, hockey for physics is nicer than football because ice is nearly frictionless. After the collision, you do keep going roughly in a straight line at a steady speed. Roughly. As opposed to on grass where you come to a stop pretty quick. When suited up in hockey gear, George weighs 65. He's skating east. Alrighty, Mr. Dueck. Mass A. You know what? I'm going to use G for George and J for Jim. East. I call that positive, so that 12 is positive. West. That 4 is negative. East. That 4 is positive. Okay, here we go. The sum of all the initial momentum equals the sum of all the final momentum. There's 2 objects, there's a collision. This is a job for conservation of momentum. Before the collision, what's moving? Both Jim and George. So I'm going to have mass George, V George initial, plus mass Jim, V Jim initial. Wham, they collide. Afterwards, stick together or separate. It looks like separate. By the way, is this collision elastic or inelastic? Elastic? Oh, rubber band bounced apart. Yeah, they bounced apart. Okay. As opposed to inelastic, which is not bouncing apart, sticking together. So it's going to be mass George V George final plus mass Jim V Jim final. And it looks like, Quinn, they want me to find that. Left side's going to drop down like a domino. Then I think I'm going to minus this over and divide by that, M. It's going to look something like this. Mass George V George initial and mass Jim V Jim initial minus the leftover momentum that went into George, divided by the mass of Jim. That's going to be how fast Jim is going. Is that right? I hope. Let's plug in numbers, Mr. Dueck. The final velocity of Jim, what was George? 65 and 12. 65 times 12 plus 85 times -4. And then there's a minus, and I want mass of George, 65. Final velocity of George, +4. All divided by mass of Jim, 85. I don't know who's going to win this collision at all. The final velocity of Jim is going to be bracket 65 times 12 plus 85 times -4 minus 65 times 4, close off the top, divided by 85. Y'all get 1.74? Am I wrong? Anybody else get that? No, so I made a typo. Oh, you know what? I typed a 62 here. Let's fix that. Do you get 2.16? Now people are nodding. Okay, 2.16. Positive or negative? I got a positive, so that direction is east. Let's talk about what types of answers. You could also have gotten a negative answer. That would mean that Jim ended up going back in the opposite direction. Could also have gotten a 0. It's possible they could have collided and their momentums could exactly have canceled each other out and they could have come to a stop. I think there might be one on your unit review like that. Yeah. Oh, am I still wrong? Yeah. Okay. So when people said yes, wow. 85. Thank you, Caleb. How about 2.117? That better? Okay. Let's try that again. 2.1. 2.12? Yeah. And by the way, Austin's laughing at me, as you should, but this is why I try and tell you, be organized but lazy, but be organized. It's worth getting a good calculator, for example, lets you backspace and catch those things, right? 2.12 meters per second, and it was positive. What direction did I let be positive? East. If you got that right, I would give you 3 out of 3. Otherwise, I would probably do something like this. I would probably go 1, 2, yeah. I would go half mark for that, half mark for that, half mark for the numbers, half mark for that, half mark for that, and heck, I might even give you a half mark if I saw that. Can you give yourself a lovely score, please, out of, what's this one out of? 14, please. Is it out of 14? 3 and 4 is 7. Yeah, okay, 14. Give yourself a score out of 14, please.